Hello students. The another category of problematic soils is vertisols and acid sulfate soils. Of course, they are in less occurrence, but they are very important. There is a quite good area which is also been affected because of these problems. So we will be discussing them in one by one. So before first we will be discussing about the vertisols, what are the vertisols and how we can manage these soils, and similarly then we will be taking up acid sulfate soils. uh, the vertisols are a specific group of poorly drained fine textured soils, and most poorly drained clay soils generally found in sedimentary plains both on level lands and in depressions. Vertisols are found on hill slopes and Piedmont plains. They occur in climate ranging in subhumid, temperate, Mediterranean or semi-arid regions, and the clay content is very high. So this is very important that in these soils, which comes under the vertisols, they are normally have high clay content. Now this is you can just can logically correlate that there is a high clay content, and secondly these are sedimentary in plains. So what happens that when during rainy season, or you can say the deltoid soils, what happens is lots of soil is coming up with erosion of with the water. So you must have seen that muddy waters flowing during your monsoon period in rivers and rivulets. Now, once they reach the plains, they start settling down there, and the suspension of the soil is settled. Now, this soil is having very fine particles, and obviously, these are like clay, and naturally, the concentration of clay will be increasing. They may be present here, and because of being in the smaller size particles, they have the poor drainage and all in this conditions. Now problems is vertisols have very hard consistence when dry. They are very plastic and very sticky when wet. Generally, tree face problems. They lean when soil is wet. Roots are broken when cracks develops in dry uh, uh, season. So flooding can be major problem in areas with high rainfall because stagnant water can hamper tillage operations in these soils. So this is about the problem with the vertisols. Uh, Now here this is the ways to do is evacuation of excess surface water, the gully controls, storage of water with in the watershed, water harvesting in areas with vertisols, and how to do the water harvesting by construction of small ponds, contour plowings, vertical mulching, construction of tight ridges, and all that. Then improvement of rooting conditions by soil heating, burning, or fallowing on deep plowing. So the deep plowing is one of the measures so that the soil on the surface get mixed up below with the below ground soil, and as such there is a breakage of the surface hard pan also. So these soils can be made suitable. Now the next is about the acid sulfate soils. So this is another segment in which normally present in drained coastal wetland soils, very high acidic soils. Their pH is less than 4. So you can just imagine that they are just like acid, and due to oxidation of pyrites, this is the pH which goes to so down. The undrained soils containing pyrites need not be acid, and they may be called potential acid sulfates. Now the types of acidic sulfate soils is potential acidic sulfate soils. So this is ASS, which has not been oxidized by exposure of air, are known as potential acidic sulfate soils. And they have neutral pH around 6.5 to 7.5, contains unoxidized iron sulfides, soft, sticky, and saturated with water, and are usually gel-like muds, but can include wet sands and gravels. Then there is a actual acid sulfate soils. So this is the soils where the past has exposed to oxygen, or you can say the potentially acidic sulfate soils. They have been exposed, and then there is iron sulfides are oxidized and produce sulfuric acid, and the soil becomes strongly acidic. This is almost below, goes to below 4, and these soils are then called actual acid sulfate soils, or AASS. So this is the difference between PASS and AASS, that this is the actually acidic reaction has already been happened in that, whereas in potential there is the these are the soils, but once they come in contact with oxygen they can go for actual acid sulfate soils. Now the pH is less than 4, contain oxidized iron sulfides, vary in texture, and all this. So the occurrence in India is, where there is a high iron sulfides present. It's the areas which are strongly acidic when drained are termed as acid sulfate soils, and as such, the Dutch refer to those soils as cat clays. When allowed to develop acidity, these soils are usually more acidic than pH at 4.4, 4, sorry. Before drainage, such soils may have normal soil pH and are only potential acidic sulfate soils. Generally, these kind of soils in the country are present in coastal areas, and this is like Kerala, Odisha, Andhra Pradesh, Tamil Nadu, West Bengal. These are the areas where these kind of soils are more dominating. The formation of such soils happens due to the land inundations with water that contains sulfates, particularly salts. Water accumulates sulfate compounds, which is poorly aerated soils are bacterially reduced to sulfates, and such soils are not usually very acidic when first drained in water. When soil is drained, then aerated, and sulfides is oxidized to sulfates, and by a combination of chemical and bacterial action and forming sulfuric acid. So this is the reason, the acid forming is the reason to lower down the pH and making the soils like acidic. The magnitude of acid development depends on the amount of sulfides present in the soil and the conditions, the time of oxidation. If iron pyrites is present, the oxidized iron accumulates the acidity, but not as such. Aluminium is normal acid soils because the iron oxides are less soluble than aluminum oxides, so they hydrolyze less. So these soils are the soils normally with iron pyrites, and this is can be a sore ore of iron also. But these soils, when comes in contact with oxygen, they make acid sulfate soils. The typical characteristics of an acid soils, or acid sulfates are, they contain sulfuric horizons which has pH of 1 is to 1. Soil and water ratio is less than 3.5, plus some other evidences of sulfate contents, and there is a yellowish coloring in that. Such strong acidity in acid sulfate soils result in toxicity of aluminum, iron, soluble salts, and all that. And these salts may sometimes produce the H2S also, which gives this as a rotten smelling, or the soils smells like rotting. And normally this is sometimes, if we grow some rice in that, this may cause some diseases in rice also. So the typical management of such soils is, uh, you know um, keeping the area flooded, maintaining uh, the reduced anaerobic conditions, soils imbibes acid development, and use of area for rice growing. So, if we grow rice in such areas, this is making the soils, little productive also, and so rice can, you know, bear the anaerobic conditions and can survive in such soils. The limitations with such soils is unfortunately drought occurs and can short periods and cause acidification of these soils. The water used to flood the potential acid sulfates often develop acidity and injure crops. Controlling water tables. If a non-acidifying layer covers the sulfuric horizons, drainage to keep only sulfuric acid underwater. So sometimes we go for liming also. We plan just like acid soil reclamations. The calcium is a hydroxide, which is the lime, is also used in these soils so that the calcium can alter the um, uh, nutrients concentrations and can be improve the pH also, and these soils may become suitable for plant growth.